Hello students, welcome. Previously, we were dealing with the application of the electrochemical cells or voltaic or galvanic cells, and we said the redox reaction in an electrochemical cell or a voltaic cell or galvanic cell is commercially applied to make the following. Part A, dry cell, which we refer to them primary cells. A good example, we have taken the Leclerc cell. But B, we had the wet cells, which are also referred to as the secondary cells, they are known as accumulators. And the good example that we have picked there was the lead acid accumulators. So in our previous class 9, we were dealing with the wet cells or the secondary cells. So today, lesson 10, we are going to proceed to the fuel cells. And we said each of these cells will be explained in detail. So today, we want to go to the fuel cells. And a good example that we are going to pick there will be the hydrogen-oxygen cell. So we're saying fuel cells are electrochemical cells which convert the chemical energy of a fuel directly to electrical energy. And we are saying a good example for fuel cell is the hydrogen-oxygen cell, and this is how it looks like. We're saying hydrogen-oxygen cell involves the passing of hydrogen and also oxygen into potassium hydroxide electrolyte. So when you remember, when we are dealing with primary cells, we were having the mixture of zinc chloride and ammonium chloride based, which was acting as our electrolyte. When we are dealing with secondary cells or wet cells or accumulators, we were having concentrated sulfuric acid acting as our electrolyte. Then today, when we are dealing with the hydrogen-oxygen cell, we have aqueous potassium hydroxide, which acts as our electrolyte, or we can even use sodium hydroxide. So we're saying this fuel cell involves passing hydrogen and also oxygen into concentrated or aqueous potassium hydroxide via carbon electrodes. That's the carbon electrodes that we have in these two sides. So we're saying next, at the negative terminal, hydrogen reacts with hydroxide ions. So where are these hydroxide ions coming from? Remember we said the electrolyte there is potassium hydroxide. So when it dissociates, it produces potassium ion and also hydroxide ions. So that's why we're saying that at the negative terminal, hydrogen reacts with the hydroxyl ions to form water and electrons are released. So the question that takes place at the anode is that 2 moles of hydrogen gas will react with 4 moles of hydroxyl ions to give us 4 moles of water, which is liquid, and these are the 4 electrons that we have lost. So we're going to go next. We are saying at the positive terminal, oxygen and water accepts the 4 electrons lost from the anode to form again the hydroxyl ions. That means the hydroxyl ions are regenerated again. So the question that we are going to have at the cathode will be oxygen gas and 2 moles of water liquid will acquire 4 electrons, or will accept 4 electrons lost from the anode to form 4 of hydroxyl ions, which are in the aqueous state. So let's have the overall cell reaction in the hydrogen-oxygen cell. And for us to get the overall cell reaction, we are supposed to add the anode reaction and the cathode reaction. So if you see something on the reactant side which appears on the product side, we are going to cancel out. Like 4 electron will go with 4 electron, 4 of hydroxyl ions will go with 4 hydroxyl ions. If you check the number of the number of moles of water that we have here is 4, and here we have 2. So what we are supposed to do is we subtract. We are going to get 2 will go with 2. So here we are going to have 2 moles of water. So the overall, we are going to have 2 moles of hydrogen gas plus 1 mole of oxygen gas. Here we are going to get 2 moles of water on the product side. So we're saying the cell does on producing electricity as long as hydrogen and oxygen are fed into it, so that it does not become exhausted like a primary cell. So what does that mean? As long as we have, or we fed hydrogen and oxygen into that fuel cell, it keeps on producing energy. So we're saying the fuel cell, unlike secondary cell, does not store energy. We're saying the electrode, other than completing the circuit, also catalyze the reactions in which increase input of the cell. The reaction rate of these electrochemical reactions is low with the help of a catalyst such as platinum catalyst or palladium catalyst. That's why when we check the fuel cell, we are going to have their finely divided platinum. So that's why we're saying we are going to use platinum catalyst to catalyze the cell reaction. Learners, that's the end of our video today. Thank you for watching.